So most of you already submitted your quiz, except for one who emailed me because she is affected by, I think, the typhoon in Cagayan. Okay.
Sino, Kenver?
It's Pascual. I think she's my student.
Okay. Hanapin ko lang yung mga students ko.
Brown out daw sa kanila eh. Kaya, ano, hindi siya makaka-submit on time. And if you're going to look at the deadline, ang problema kasi yung time zone natin. So to be safe, kasi ang problema ngayon, pag sinet namin yung deadline, wala na kayong access past the deadline. So to be safe, I set it at 11:30 pero Tuesday US time. Kasi pag sinet ko yun ng 11:30 na ganitong time, magsasara yun ng 11:30 ng Tuesday pero 11:30 p.m. pero Philippine time. So to avoid that thing, inano ko na doon sa time na yon. Kasi nilagyan na namin yung after the deadline, hindi na kayo makaka-access. Yun yung ginawa naming changes doon sa quiz natin. So we are now going to module 3, and if you have started reading those materials, you could see that there's a lot that we need to cover. So this may be the start of our synchronous, and then I'll start also at the same time to record a synchronous lecture. And then from time to time, okay, we're going to meet. So I will go over some of the material and I'll focus more doon sa material na ibibigay namin as problem set or quiz. So expect to have problem set, I think, every meeting. So we will give 2 to 3 problems related doon sa material. So these problems are usually calculations. So if we have lectures, like if we're talking about principles of the instruments, most likely there's no problem set. And then what we do, okay, we might cover, if you're going to look at the study guide that we have, there are some portions at least on module 3. So I don't know if you could see the PDF file. So there's the extraction that we're going to cover today, the theory of chromatographic separations, and then liquid chromatography, gas chromatography, the supercritical fluid chromatography, and electrophoresis. So I think after we're done with liquid chromatography, we're going to have a quiz that covers these 3, what we call subheadings. But in every subheadings, expect to have problem set. So what we're going to do, we're going to post the problem set, and then all you need to do is answer it right away and then upload it in our Google Classroom. So medyo magiging busy na tayo. Okay? So without further ado, we're going to start module 3. So we're going to have the introduction to analytical separation. So we're not going to go straight to chromatography, because if you're going to look the technique of chromatography, this is really more on separation techniques. But unlike the other instrumental methods, when you're doing analysis using chromatography, you cannot just directly inject your samples to LC, LCMS, HPLC, LCMS, or GCMS. You have to do some sort of sample preparation. Okay. Now, the main reason for that, first is, of course, separation. You want to separate the target analyte from the other compounds that are present in your matrix. And the other one, aside from separation, is the so-called pre-concentration. Because it's not enough, okay, if you're going to directly inject your sample to your instrument. So usually the amount that you have there is so small that it cannot be detected by the instrument. So by doing sample preparation, aside from separating it from other compounds that are present in your matrix that can interfere the analysis, you're also pre-concentrating, okay, the analyte that you have. So that's what you're really doing here, okay? So at the end, at least of this, we could say unit, you should be able to describe the importance of sample preparation prior to quantitative analysis. And then recognize the properties of the analyte that can be used to separate it from a mixture, okay? And then I'm going to discuss some about the different extraction techniques, such as the liquid-liquid, Soxlet, okay? SPE and quenchers. And I'm also going to share to you my experience in this extraction technique, okay? And then once you learn the principle here, you should be able to predict the best extraction method for isolating the analyte given a sample scenario. So ang end goal natin dito, you will learn the principle, and when you're given a problem, you should be able to know which extraction technique or method you're going to use. Okay? So the thing that we do, as I have told you, you cannot directly analyze right away the sample that you collected. In most chemical analysis, okay, you have to do some sort of sample preparation, okay? And the main reason for that is the compounds present other than your target analyte can interfere with the analysis. And what you do, you have to remove them or mask them, okay, during sample preparation. So these are the common things that they usually use. There's a distillation, the precipitation. So in distillation, you're looking at the difference in the boiling points, okay? Precipitation, you're looking at the difference in solubility. So centrifugation and filtration is just, we could say, removing some undesirable, let's say, solid particles. So centrifugation, you centrifuge it, you let the solid particle settle at the bottom, okay? And in the filtration, you separate some insoluble materials, okay, by using a filter paper, okay? But the one that is common is what we call extraction, okay? And you do extraction usually before you do chromatography, and that's the focus that we have in this chapter, okay? So the one that we're going to talk about extraction, we could say the liquid-liquid extraction, the liquid-solid extraction, and the gas-solid extraction. So the way that we're going to look at this is we just transfer from our sample the analyte that we are targeting, okay? Let's say from a liquid component to another liquid component, but the difference in their solubility. Now, I don't know if you have taken your 43, 44, right? Hindi ako makasulat eh. So, in the liquid-liquid extraction, it was done. Are you familiar with the separatory funnel? The SEP funnel. So usually you see there are 2 layers. Okay. So that's the example of this, what we call liquid-liquid extraction. And usually, you see 2 layers because they have different solubility. Ang ano nga doon, yung isa aqueous layer and the other one is an organic layer. Okay? So in the liquid-liquid extraction, and this is the most common, we could say, extraction, it's based on the transfer from one liquid phase into another immiscible liquid phase. So immiscible, so that means they have different solubility, what we call miscibility. They have different, we could say, one is aqueous layer and the other one is an organic layer. according to the difference in solubility. Now, what good with the liquid-liquid extraction? It can both reduce the matrix interferences. So if you notice in our module 1, we talk about how matrix, okay, can affect the analysis. So usually matrix can become more complicated if you have other substances or other compounds that are present in your sample. And the more complicated your matrix is, the harder it is for you to do an analysis, or the more interferences that you can get. Okay, so using liquid-liquid extraction, what you're trying to do is you try to isolate your target analyte from the other components that you have in your sample. Okay, so it can reduce the matrix interference and facilitate the concentration of the analyte. So you have separation here, and at the same time, pre-concentration. So those are the two important things that we have in sample preparation, especially if you're using this sample for chromatography. Okay, spectroscopy, you seldom do it. Okay, but chromatography, because you try to get especially if you have a sensitive instrument, the lower the concentration that you have, okay, the harder it is to be analyzed. So in the liquid-liquid extraction, as I have told you, there are two phases here. So you have phase 1 and phase 2, okay? So one of them we could say is the aqueous form, and the other one is the organic form. So you can assign one as, we could say, the aqueous form, and 2 as the organic form. And in between them, we always have this, what we call partition coefficient. So if we're going to look at this partition coefficient, this is just some sort of expression in terms of the concentration, okay, of the substance that you have, or the solute that you have in the 2 layers. So the one in organic layer over the one in the aqueous layer, okay? And if you go on to look at what you can get from these fractions of your analyte, okay, remaining, let's say, in phase 1 after 1 extraction, we can determine this partition coefficient. Okay, so if we're going to look at what you have here, so you have here the M, which is the mole of your target analyte. Q, that's the fractions of mole of your target analyte remaining in phase 1. So maybe we could say this is the aqueous layer. And then P is the fraction of moles that's transferred to phase 2. That could be our organic layer. And then we have here the volume of phase 1 and the volume of phase 2. So of course, if we're going to add the fractions of mole of S remaining in phase 1 and the one that transferred to phase 2, okay, that's always equals to 1. So we could say our original sample was in phase 1. And what we're trying to do is we try to transfer the analyte, the target analyte that we have in phase 2. So if we're going to look at the concentration of the solute in phase 1, so we can assign phase 1 as Q times the mole of S in the system. And then the one in phase 2, that's P times mole of S. And since Q plus P is equals to 1, we can just represent P there as 1 minus Q, okay? To simplify the thing so that you can express both of them in terms of Q, okay? And if you're going to continue replacing the solubility in phase 1 and solubility in phase 2, or aqueous layer and organic layer. So we're going to replace it here in our partition coefficient. So what we have here, okay, the PM over B2 over QM over B2, and we're going to express P in terms of 1 minus Q. So you end up with this expression. I think this is the most important thing that we have here. And rearranging this one, we're going to have this equation where we have this Q. Okay. And Q, this is just the fraction, okay, of the moles of your target analyte in the aqueous layer. But this is just for single extraction. But if you have multiple extraction, you can put there as Qn equals to B1 over B1 plus KB2 raised to the n. Okay. And assuming here that the volume that you use in the extraction is constant. So I don't know if you have experience in your organic chemistry lab, because usually there's a separatory funnel, and then what do? We put the next layer there, and then we mix it, and then after some time we recover it. And then we mix it again with another volume of the organic layer, and then we recover it. So the question now, which is more efficient? One extraction with big volume or large volume, or multiple extraction with small volume? Okay, so that's this problem is all about, the first one here. The solute A has a K equals to 3 for an extraction between water, which is the phase 1, and benzene, which is phase 2. So I told you, phase 1 is usually the aqueous layer, and phase 2 is the organic layer. Now, if you have 100 ml of a 0.1 molar solution of A in water is extracted one time with 500 ml benzene, what fraction will be extracted? So you're just going to use this equation and then fill up the given information. So the volume of the one there, that's 100, okay, divided by 100. And then the K value that you have there is 3. And then the volume of your organic layer is what we call 500. So you're going to get there the Qn. Now the Q represent the fraction that you have in A. But if the one that's being asked is the fraction that is extracted, that's the one that went with the benzene. So all you need to do is subtract 1 with this value, and you're going to get that this fraction 0.938. And all you need to do is multiply it by 100 to get the extraction efficiency. That is 93.8. So kaya ba to? I think the slides, the material itself is self-explanatory. Okay. Now, what if instead of 500 ml, that's one time, what if we do it multiple times, but with small volume, like the second problem? So the same system, the only difference is this. The 500 ml that you have for benzene, what you did is divide them into 5. Okay, so 5 extraction with 100 ml. So what changed? The formula remains the same, but you now put this n raised to the 5 because you have 5 extraction. And the volume that you have, instead of 500, you're going to use now 100. And based on the calculation here, you get the value of Qn as 0.0098 or 0.001. And you subtract that with 1, okay? So the extraction efficiency is 99.9%. So I don't know if you have learned this concept that it's better to do liquid-liquid extraction in small amount but multiple times than one time with large volume of your extracting solvent. Because as you could see here, for the same 500 ml of benzene, more solute is extracted when several small portions of benzene are used. And the number tells you so, 99.9% versus the 93.8%. So question. May tanong? Kaya mag-solve ng problem na ganito? And to show you the summary on how multiple extraction is more efficient than single extraction, I think this graph shows you that the effect of the number of extraction has on the extraction efficiency in liquid-liquid extraction. So as you could see here, as the number of extraction increases, okay, the extraction efficiency increases also. But as you could see after, I think, fourth, the change in terms of efficiency is already low. I think it's not practical anymore to go, I think, way beyond 5 extraction. You're just wasting your time, okay? Because there's really not much improvement, because by 5, you have already a 99.9. Okay? So the effect diminishes quickly as the number of extraction increases. So I think the most practical here is you stop by 5 extraction, because more than that, it's not practical anymore. So question so far. Now let's look at another problem, but this time this is from another perspective. So it says here 3 extraction with 60 ml portions of chloroform remove 98% of a solute from 200 ml of an aqueous solution. And the one that you're being asked here now is to calculate for K. So K naman ang pinapaano sa inyo dito. What is K? Okay? O yung tinatawag na ano dito. So the way that you're going to do it is you rearrange itself here. Maybe you can start with this one. Now the question is, how did you end up with 8.9? Paano nyo isosolve to? Anyone? Solver? Nagamit na kayo ng solver ngayon? But let's say we do it the old mathematics way. How do you simplify this one here? How do I eliminate the raised to the third here? Can I just put the cube root on both sides like this? Medyo malaki nga alam kung ano ko dito. Oops. Ayaw niya mag-ano. So the cube root here. Ayaw niya mag-ano ng 3 eh. Okay? So with that case, may eliminate yan. And if you're going to do the cube root here, so maybe I can, what we could use, what's that? I'll use this one. Okay? So if you're going to look at this, that's 0.020 equals to 200 ml over 200 ml plus 60K. And then you have the third, right? So what you're going to do, you're going to get the cube root here. So ano yung cube root niyan? If we're going to solve this problem. So if we're going to solve this problem, I think the cube root that you have is around 271. Okay. And then you have the 200 ml here and the 200 ml plus 60K or K60. And then cross multiplication. Tapos kung ano man yung makuha nyo, I think you can get here around 54 16.29, and then you're going to get here around 16.29 K. You have 200, and then put everything on one side. So you have here 254, no, not 254, because that's supposedly minus. And all you need to do is divide both sides by 16.29. And I think you're going to get there a K that is around 8.9. So what do you think? Can you solve problem like this? Because that's the one that I put in our problem set. Kaya?
Kaya daw, Elmer.
I think the focus of my problem is this one. Dalawang problem yung nilagay ko because this is easier than the next one. Okay? So the next one, share back to you. So the next one is, what if we have pH? So sometimes the best way for you to separate one component is by changing its pH. So maybe by making it basic, you protonate the compound and it becomes more soluble. Or if you, no, not deprotonate, if you increase the pH, or if you decrease the pH, you protonate the sample, and that's what we call separate that target compound from your sample. Okay, so they take advantage of this protonated and non-protonated form. And even I usually take advantage of this one if I want to analyze and I know that there is more than one free hydrogen in the target analyte. So I can separate them by taking advantage of change in pH. Because what do you learn from Gen Chem? Once you have a charged species, most likely it's soluble in aqueous solution. Okay, so they have also protonated and non-protonated form, different partition coefficient. So the one that is usually extracted are the neutral form, because the charged form are usually soluble in the aqueous layer. So if you're going to look at the difference of the pH, how you take advantage of this one. Okay, so usually in the aqueous layer, they are in the proton charged form. So if you're going to make them into the neutral form, you can separate them. Just as in here, whether you have an acid or a base component. Okay, and it's the same thing in terms of what we call the effect of pH. So it just has something to do with the partitioning based on the concentration of the solute between the two phases. So you can put there an organic layer and an aqueous layer. Okay, so you can do a base like this one, D, which is partition thing, equals to the concentration of base in the second layer, or the organic layer, over the concentration of base in the aqueous layer plus, okay, the protonated form that you have there. So you can express also the partitioning in terms of KB and Ka. If you're going to recall your general chemistry, I think Gen Chem 2 and analytical chemistry, the quantitative analysis, Chem 32. So the way that you're going to express them here, okay? So if you have it in the basic form, so this one here is just manipulating the equation that you have here. So you have here B2. So you're just going to express here B2 in terms of this. So, ang hirap kasi no, hindi masulat na malit eh. So you rearrange their B2 is just equals to KB times B1. Like what happened here. So B1 is the same. And then you're going to express BH plus here, BH plus 1, by just rearranging this one. So you put BH plus 1 in one side, and then it would just be H plus times B1 over Ka, as what you see here. And if you're going to simplify them, this is what you get. D is equals to Kb times Ka over Ka plus the hydronium ion concentration. Now you can also express it in terms of the HA, the acid, okay? And following what you did there in the base, this is what you're going to get, okay? So KHA, the acid dissociation constant times the hydronium concentration over acid dissociation constant plus hydronium ion concentration. And there's an example that was given here. So if you're given the partition coefficient of B, I mean B is equals to 3, and the acid dissociation of BH plus is 1.0 times 10 to the negative 9. So 50 ml of 0.1 molar aqueous amine is extracted with 100 ml of solvent. What will be the formal concentration remaining in the aqueous phase at pH equals to 10 and pH equals to 8.0. So unlike the previous problem that we have, this consists of multiple calculation. But you're just going to use the formulas that given here, either this one or this one, the one that you have here, or this one. And we already put here, okay, the solution on how to use this thing. So since both of them are in basic pH, so we might just use the one that is what we call the one that we have here. Okay, so we have the value there 3 times 1 times 1.0 times 10 to the negative 9 over 1.0 times 10 to the negative 9 plus 1.0 times 10 to the negative 10. So this H plus this one, that's the one that you get based on the given pH. Okay, and if you're going to look at the other calculation, instead of 10 to the negative 10, you have a 10 to the negative 8. So this is a pH 8 and this is the pH 9. Now the thing here, you're just getting the value of your D, which you're going to use as the value of your K in the next calculation, similar to the one that we did earlier in the liquid-liquid extraction. Okay, and the one that you will get there is the mole fraction that remain in your aqueous solution. And then once you have there the mole fraction that you have, you're going to multiply it with the initial concentration because you're being asked for the formal concentration. So this is a little bit more calculation compared to the previous one. That's why I removed some of these things in the problem set. So one here, you could say the formality is 0.0015 and the other one is 0.0065, which means as the pH becomes more basic, you have less of the material, okay, in your aqueous form. Or there are more materials that is being extracted, okay, in the organic layer. That's the interpretation that you have. Question. This is just the calculation part that we have here in this module, at least in this 3.1. And if we're going to summarize what we have here, so this is what the effect of pH on the extraction efficiency of B. Okay, so if we compare the two conditions at pH 8, the base is in the form of BH plus and remains in water. That's why you have a high Q. So that means it's mostly on the aqueous layer. But at pH 10, the base is predominantly in B and is extracted in the organic phase. That's why there's low Q on the mole fraction of your B in the aqueous layer. So that's the interpretation that we have here. Questions so far before we go with the next extraction method? Tanong? Ma'am, baka may i-add kayo.
So far wala naman, pero ang maganda kasi dito nakikita talaga yung mga observations na explain mathematically. For example, yun nga, pagka one extraction lang, yung extraction efficiency talaga mababa kaysa yung sa benzina. Sineperate into 5 times yung 500 ml. So 5 of 100 ml each. So nakikita talaga na mas maganda yung yung extraction efficiency. So yun kasi na-observe natin sa sa organic, sa 43, sa 44, di ba? Laging sa procedure, extract twice or thrice. Kasi yun ang purpose. Mas maganda ang extraction pagka parang mas maganda ang extraction pag madaming times kaysa yung isang extraction lang. So here, yun nga, na-explain natin mathematically with the equations. So sana may appreciation itong yung ating mga children.
So that's the liquid-liquid extraction. So the next one that we have, okay, you can read more about the liquid-liquid extraction in this what we call chemlibretext.org, okay, and the Harris book. Okay, so I think they use 8th edition, but the Harris book now is 10th edition. Okay. Now, the next one that we have is solid liquid extraction. So how is this different from the other one? So your sample here is usually in solid form. Compared to the previous one, you dissolve the sample in the liquid and then mix it with another liquid that is immiscible so you can extract here. But here in the solid liquid extraction, okay, either you have a solid phase where you pass your sample in a liquid phase, or you have a liquid solvent and you have a solid phase sample. Okay, so analysis of solid sample is one of the most challenging tasks in sample preparation owing to the complexity of the sample matrix. And the most common one that we have here is Soxhlet extraction. I have experience doing Soxhlet extraction when I was still in IC, and that was 20 years ago. And I'm not sure if they still have this setup. So there's really a Soxhlet setup there. And then you have here, I think, is that, ano ba tawag dito, ma'am? Timbol? the white thing?
Oo, timbol. Ano, meron pa niyan kasi ginagamit yan sa 131.
Meron pa rin po. So,
doon sa yung technical analysis of food and feeds, so sa crude fat, yan ang ginagamit nila yung
So, dyan sa timbol na yan, I mean, I used that also here at the beginning, and then the organic professor was laughing at me. Why are you using some crude material? So, yan sa timbol na yan, you put your sample there, and then you have your solvent here. You evaporate it, yung parang hinihit mo lang. So, ang mangyari yan, kapag nag-vaporize yun, magpapass through doon. Tapos, kapag nag-condense siya, okay, mag-aano siya dun sa sample, so makokollect mo yung extract niya. So paikot-ikot lang yan, yung solvent extraction na yan. Okay? So yan yung tinatawag na Soxhlet extraction is a continuous solvent extraction method. But I think they have now this automated one. I think Soxtec ata yung tawag yung last time na nandyan ako sa IC. So they're using this what we call thing. The same principle as the Soxhlet. Okay, automated lang siya. So you boil your solvent, tapos let it condense and then pass through doon sa sample na meron ka. Okay? So it's a three-step analysis: the boiling, the rinsing, and the evaporation. So at least they have automated one. So I tried to use this here because I'm trying to look which extraction method is the best to extract properly sample, which is the big blue. So one student of mine compare different extraction. One time he uses Soxlet, pero nahihirapan din siya. Ayaw na iwanan without my supervision. So he just went away with this one, and instead of using this one, he used the soaking method, where you soak your solid sample in a solvent, and then the microwave method, the one that you know as microwave to heat your food. We have a microwave designed for some solid samples here, and then we also use this ultrasonication. And the one that I got from NSF, the accelerated solvent extraction or pressure liquid extraction. Yung parang tawag namin dito yung, I don't know, are you familiar with kurig? Yung kurig sa coffee or tea, na ano nyo. So the pressure liquid extraction, you can increase the temperature and the pressure, okay, in extracting your solid sample. Okay. Now, the most common solid phase extraction is the one that they use these materials. Ito yung tinatawag nating SPE cartridge. Okay? So you have an SPE vacuum manifold. So what you do here is you pass your sample through this one. So usually, if you're using a water sample, you may use around liters of volume of liters. Okay? Because what you're doing here, aside from separating your target analyte from the other compounds that you have in your sample, you're also concentrating them or pre-concentrating them. Okay, so it involves separation of components from a liquid on to the solid extraction medium. So the one that they usually use is the reverse phase, which is C18 and C8. And those are also the common materials that you use in chromatography. In fact, this has the same principles as chromatography. The only difference, you only use low pressure here because you want them to go down as much as possible compared to the one that is packed in the column where you use high pressure. Okay, so you can also use normal phase that contains NH2 or CN, the polar functional group. Or you can also use ion exchange. Okay. Now, the main experience that I have in SPE is I developed the material itself. Okay. Using this so-called molecular imprinting polymer. So this is the most popular thing that is being used for removing, okay, or separating and concentrating trace organic materials for aqueous media. So before I share to you my experience, I just like to tell you, these are the different SPE cartridges that you have. So those are the materials that you need there. And my experience in using SPE is prepared that materials that I have there for some target analyte. Okay, so the benefits of the SPE, we switch some sample matrices to form more compatible with chromatographic analysis. So the way that they do is it is concentrate the analytes for increased sensitivity. Kasi masyadong maliit kasi mababa yung concentration ng mga analyte. So that's why if you use your sample, inject it as it is, you won't see anything. So this is solved by using SPE. So you pass volumes in liters of the sample, so you concentrate them. And in addition, it separates your target analyte from the other components that you have. It removes the interferences to simplify chromatography and improve quantitation. And it protects your column from contaminants. So at least parang ano nga nila dito, it's also another way of sample cleanup. Okay? So there are three strategies that you have in the SPE. You have the bind elute strategy. So this is the one that's most common. So when it binds, the analyte binds to the tube and the unwanted matrix components are washed off. And then you elute. So once nag-bind sila, it will remain in the solid materials there. And you can only remove them when you add an LU1 that changes. Okay. And remove the analytes from the tube. And then once you collect it, you still concentrate it, maybe using nitrogen gas, okay, or evaporation, okay, before you use it for HPLC-LGC analysis. Another strategy there is the interference removal strategy. So you bind all unwanted matrix component and allow analytes to pass through during the sample loading state. It's just like a chemical filtration. And then you can also have this fractionation strategy in the form of bind elute. So the way that you do it, you retain and sequentially elute different classes of compounds by modifying the LU1 pH or percent organic composition. In fact, some use more than one SPE. So itadaan nila sa isang SPE cartridge with a certain property and then pass it again in another cartridge with another property. Okay. So the way that you look at these, what we call steps, especially in the bind and elute strategy, you condition and equilibrate the sorbent. So the way you do it, you prepare the sorbent for effective interaction with the analyte solvate sorbent and remove the air. So usually, ano yan, meron kang vacuum pump because you need pressure. Okay. And then you're going to load the sample. So you extract the target analyte while the matrix interference pass through the tube unretained. And then you wash the sorbent. So in washing it, you remove the weakly bound impurities. So this is the cleanup. So ang may iwan doon sa solid particle mo ay yung nag-bind. And then you elute the target analyte. So you remove the one that bind. Okay. So you selectively desorb target analyte from the sorbent. So it's just all a matter of what we call using the appropriate solvent. Yun yung experience ko dito. Okay? So before we go with the questions, I like to share to you yung experience ko in the SPE. So this SPE that I did, that is part of my what we call the dissertation. So when I did my dissertation, we have this problem of antibiotic residues in the environment. So we're targeting this group of antibiotics known as the tetracycline. So this is one of the mostly used group of antibiotics, especially in animals, because we use it as a growth promoter. So it's hard to analyze them because when you find them in complex samples like food, surface water, soil, and animal manure, there are other components that are present in greater amount compared to them. And the problem that we have is it can easily undergo transformation processes. Effect of heat, effect of light, okay, effect of pH, even its interaction, let's say, with some clay or soil or minerals, make it very difficult to be analyzed. So different sample preparation always give us different results and low recoveries. So the idea that I have during that time is we use the Sol-Gel process. So the Sol-Gel process is just formation of materials that is similar to the what we call glass. Okay? So ang nangyari dito sa Sol-Gel process, when we mix these silanes, it undergo hydrolysis. Okay? And what happened from a liquid like system, when it undergo condensation and polycondensation, it becomes solid. That's why ang tawag na diyan sol-gel process. Liquid becoming what we call the solid. Now, the idea that we have there, while we're doing that, we're going to trap the tetracycline inside the sol-gel. So we're basing it to the so-called molecular imprinted polymers. So the only difference why we call it serogel, polymers is usually more organic substance, but the serogels is more inorganic. So in the idea that once we have the materials, we're going to remove it using the pressure liquid extraction with the hope that there are some imprints or template that are left that will bind when we use it for our what we call target analyte in different environmental samples. Okay, so the way that we do is I prepare different formulations of the molecular imprinted serogels based on the functional groups of the materials that I have. I use like a computational approach, and then I determine also the TC imprinting mechanism with serogels. Okay, so these are just some of the functional group silanes that I have. So I'm taking advantage of this functional group based on its ability to bind, hopefully, with the tetracycline. So the way that we do, this is the serogel that it forms. So the difference here, this is the one with TC, and this is the one without TC. I grind them, so this is how it looks like. And then we remove the tetracycline out of it using the pressure liquid extraction, and then we monitor the washing by absorbance. And then, okay, half of them we encap because we don't want the presence of this hydroxyl group that binds with the tetracycline. So when we encap it, we make it more organic. And then we do binding studies using tritium labeled tetracycline, so we can monitor how much are bound to the material. Okay, so the encapping that we do, the mix and the mix, these are the molecular imprinted and non-imprinted. So we use this trimethylchlorosilane, okay, mixed for 24 hours, and then we wash it, we remove, and then we wash it with acetonitrile. Okay, so we just try to remove the OH that we have there because the OH functional group can bind with the tetracycline. Okay, and then we did the binding experiment. So we used the tritium labeled tetracycline. And we found, I determined the so-called imprinting factor, the amount of TC that is absorbed in imprinted serogels over the amount of TC absorbed in non-imprinted serogels. So the idea here is the higher the imprinting factor, the better, because that means the TC just bind or absorb in the imprinted serogel, which is the one that we want. Okay, and to determine that it will only bind with tetracycline, we also do selectivity study where we try to put different compounds and see how they bind. And there are also what we call radioactive labeled. Okay, so the way that we do the solid phase extraction using the material, the same thing that we have. Okay, so we activate it as what we call it. That's the condition or equilibrate. And then we load the sample that contains the tetracycline. Okay. And then we wash the sorbent and then we elute. And for comparison purpose, I use a commercial SPE. We use the Oasis HLB. Okay, hydrolytic lipophilic bonding materials. And we found out using the imprinting factor, okay, the one that we have here, a different solvent, okay, is this one. And when we encap here, the performance improved because here, why do you think it didn't improve? Because the NIX, the non-imprinted serogel, it can still bind with the tetracycline because of the presence of the OH. Okay, but when we encap it, there's no more OH, so it will only bind because of this what we call tetracycline. So we look at the reported IF in different literature. Okay, So we found out that we have a much better high IF compared to those reported in MIP, okay, in terms of the imprinting factor, but not as good as with the other antibiotics, okay? So lower IF in comparison to the other antibiotics. So we look at the uncapped serogels. They don't have what we call high IF, almost 1. So whatever that's bound in molecular imprinted is the same as the one in non-imprinted, which is really good, okay, whether it's N-cup or cup, okay? So in terms of selectivity, when we mix them together, so we found out that the tetracycline is really the one that's good, especially the N-cup. And in terms of percent recovery, well, it depends, depending on the TC analogs that we use, okay? Now, another thing that we do is, since I'm skeptic on what's really happening during the imprinting process, I try to determine what's really happening to the tetracycline while it is inside the serogel, okay? And what I did is I monitored the washing, and I found out through days, okay, the absorbance of the washing that I have is changing. So that means there's something that is happening here. The tetracycline that I have there is changing, okay, to the point that when I look at it, okay, so the initial day we have just tetracycline, but as the days goes on, okay, I lose the peak that I have there. By 3 days, there's only small amount of them, and there's new peaks that are formed, which tells me that the tetracycline changed within the serogel. So this is how it looks like. It's so big, but after several days of imprinting it there, okay, it changed. And when we found out, instead of the 445, which is the tetracycline, we found out it's just 427. And we found out that it formed into its anhydrotetracycline analog. So it's really, we could say, a battle of wits on my part, because I said, oh, if it's not going to imprint, then what is the one that is being imprinted? And that's the reason why its imprinting factor is not as high as the other antibiotics, because of its instability. And we try to look at the imprinting factor that we have there, okay? So we found out the ATC is the one that is really bound. And I have other experience that we have. So there are a lot of commercialized molecular imprinted polymers that is available. So I try to use the one that has fluoroquinolones and amphetamines. Okay. So the company give us some samples. So before I left grad school, I was able to test one that is commercially available with fluoroquinolones. So this is another set of antibiotics. So we do the same thing. Okay, the conditioning, the loading, the washing, and the elution. So it's always, we could say, the steps that you do in solid phase extraction. And then we're able to recover, okay, the 4 fluoroquinolones that we're testing: norfloxacin, ciprofloxacin, enrofloxacin, and sarafloxacin. Okay, and we're really what we call happy of how we recovered this one in the sample that we use. And then in another one, we use an MIP that targets chloramphenicol, okay? And then when I moved to Pace University, since we have a forensic science program, so what I did, I bought 2 MIP that said they can target the amphetamine and methamphetamine. So unfortunately, I only have an HPLC. So what we did, so we ran the standard. So we see the 2 peaks here that represents the amphetamine and the methamphetamine. So what we did, we spiked the amphetamine and methamphetamine standards in synthetic urine and water. And when we try to recover it, the recovery that we have is, we could say, less than what we have, than what we intend. And when we try to analyze here, the low detection limit of our HPLC is, we could say, not low enough to detect them. Now, the suspect that we have there is, since we loaded the SPE cartridge with 1 ppm, I think that is just too much. Okay, so unlike the one that I did in my PhD, we loaded the sample with ppb levels. So we could say the conclusion that we have from this study is we should at least use a lower concentration of the methamphetamine and amphetamine standard. But the problem is we cannot detect it because we are only using HPLC. So that's the experience that I have using the solid phase extraction. So question before we go back to pictures. Yeah, Mamigo knows about this because she also worked on that lab where I work.
Yeah, we we work at the University at Buffalo, the Department of Chemistry. So that laboratory is really very equipped with several analytical instruments like the LC. Marami sila doon, mga tandem. Pag sinabing tandem is mass spec is the detector. So GCMS, LCMS. Then meron silang LCMS-MS, so dalawang mass spec. So the mass spec is the detector that is hooked to the liquid chromatograph. So the separation happens at the liquid chromatograph and the detection happens at the mass spec. So may question ako, Elmer.
Yeah, yes,
for the tetracyclines kasi, you showed pictures of meat and soil. So for example, sa meat, how do you do the sample prep?
Usually, the way that we do the sample prep there, they use Oasis HLB, but they use EDTA sa extraction as extraction solvent.
Okay.
Yep.
So for if the sample is fresh meat, you just blend it with EDTA.
Yep. Because the problem with it depends on the sample. Like in soil, sometimes they are more sorbed. They are absorbed by the soil itself. So it's hard to remove them. But at least for the meat, you're just going to put some EDTA, so it breaks down some of its interaction with whatever component the meat has that binds with because the one that it may bind with in the meat is the bone, the calcium in the bone. Kasi
when you show the structure of the tetracycline, it's very hydrophobic. Yep. How about interference with the fats or the lipids of the meat? Walang problema dun sa interference?
Pwede ho, kasi meron silang yung ring apat na ring. But even though it's hydrophobic, it also have a hydrophilic component. Yung mga OH na meron sila.
And then how do you prevent the change to the analog doon sa Zerogel?
The problem
kasi ba 'di ba with time bumababa si tetracycline. So how do you prevent that?
We cannot prevent it because the Solvent process would generate acids. So kapag acidic ho siya at lower pH, the tetracycline will become anhydroform. So there's an OH that is being removed. Unfortunately, if it's basic, meron ding Solvent na basic, yung hydroxide ang degenerate, it's going to form in its what we call iso form. So ginawa na lang namin, we just monitor, okay, ano yung form niya kapag nandoon siya sa loob ng Solvent, compare siya doon sa solution.
So now there are already commercially available na IMPs.
MIP, meron po.
Okay.
But I'm always whenever I get reviews about tetracycline, I always ask them, how sure are you that it's still tetracycline that is being what we call imprinted?
Kasi nga very thorough yung yung study mo kasi ikaw na yung nag-prepare ng imprints . May question dito si Catherine, sabi niya, question lang po, pwede po kayong gumamit ng same lab kahit po sa ibang university kayo galing?
Well, it depends.
It is incidentally yung laboratory na doon nag-PhD si Sir Elmer, na-invite din ako doon. So the same lab. And our supervisor is also from the Philippines, si Dr. Diana Aga, also a graduate of UPLB na AgChem ba si Diana?
AgChem po.
Or AgChem.
AgChem po. Nagturo din siya sa IC.
Oo. So, pero kasi sa mga universities kasi, meron tinatawag na mga service labs. So, pwede kahit nasa ibang laboratory ka, hindi naman ibang university, nasa ibang laboratory ka of the same university, may mga service labs na open for you to use the equipment as long as you know how to use it. Yon. Dapat alam mo yung paano gagamitin. Although meron naman mga supervisors sa laboratory who can initially teach you how to do it, pero iiwanan ka na pagka naturuan ka na. And then ikaw na yung ikaw na yung maglalab. So ganon sa ibang bansa. They have several service labs which the students can really avail of the services. Kaya galingan nyo at pag kayo nag-graduate studies, kung gusto niyo mag-analytical chemistry na related sa environment, nako, doon kayo sa laboratory na pinuntahan namin ni Sir Elmer.
Yeah, I mean, I know some of the professors here around the US. So if you want to do some graduate study, I would say get a good grade. If you get a good grade from this course, I can give you a good recommendation letter. Yun lang man yung hinaanan nila eh. And as much as possible has some at least research experience. Galingan yung TOEFL tsaka GRE. Okay. Question? Before we end up with these quetchers. So ito yung pinaka-popular na ngayon eh. Solid phase extraction. Although I don't have any experience yet because I have a lot of SPE cartridge in my lab. Yung nakakuha kasi kami whenever I get money and when the higher ups or the accounting office tells us you have to finish your budget. So ginagawa ko, bumibili na lang ako ng lahat ng gamit until I don't have any more money. Kasi kung hindi ko gagastusin yun, they will get it back from me. So rather than return it to them, I just what we call buy some stuff that I think I'm going to need. So I end up getting a lot of these Oasis HLP. So I ran out of money to buy quetchers because mas okay itong quetchers kaysa doon sa Oasis HLP. Okay? Quetchers is usually used for food. Okay? So, ang maganda dito, ang ibig sabihin nga ng quetchers is quick, easy, cheap, effective, rugged, and safe. So, nakikita nyo yan dyan, ganun na ganun yung quetchers. Parang yung injection lang. So, pag kinuha mo, tinatanggal na niya yung mga undesirable component na hindi mo kailangan. Okay? So, yung principle is similar to the solid phase extraction of which utilize the interaction between the sorbent pillar and impurities in the matrices to absorb them so as to achieve purification goal. And if you're going to look further dito sa quetchers na to, okay, so i-homogenize mo lang yung sample mo, tapos magdadagdag ka ng internal standard doon sa tube. Okay? And you use this you add this acetonitrile, you vortex mix it, and then you add some sort of an extraction salt, okay? You shake and then centrifuge, and then you transfer the alico to the dispersive SPE cleanup tube, and then you vortex mix it, and then you centrifuge, and then it's ready for analysis when you transfer it to the vial. Okay? So, sa quetchers, meron siyang 2 steps. Yun yung tinatawag na salting out. I'm not sure if you remember doing this in your organic. Meron doon tinatawag na salting out. So, ang ginagawa mo lang doon is sinasaturated mo yung aqueous solution para ma-salt out, mapunta doon sa organic layer yung target analyte mo. Okay? So that's the first step. And then the second step is the dispersive SPE. So parang combination nga ito ng liquid-liquid extraction tsaka SPE. Okay, so yung main purpose ng SPE is to remove the polar interference. So this is very popular right now, especially when you are analyzing food. Unfortunately, yung analysis ko sa food is not something to do with this one. The food that I have is the human milk, so I don't use SPE. I do some sort of esterification, so I can get the fatty acids out of the human milk. Project po namin to ni Nasirang Al.
Okay. Oo, so sa ano yan breast milk?
Opo.
Tama, sa breast milk?
Sa breast milk. So, nandun po yung sample niya sa negative 80 degrees Celsius namin. Kasi wala rin isang gusto mag-work. Kasi nung makita nila gaano ka-tedious yung esterification, trans-esterification, sabi nila pwedeng dito na lang kami sa ibang project.
Okay.
Because different sample has different preparation methods. Okay? So it's up to you, ano ba yung target analyte mo. So if you're working like what we're doing for food here in fatty acids, then we use this, it's similar to a liquid-liquid extraction, but we try to convert these fatty acids into esters. Kaya ang tawag natin doon is trans-esterification. So we use hexane, no, not hexane, we use the sodium methoxide, and then to end the esterification, we add hexane. Tapos, isa-separate, may dalawang layer yung nagpo-form. So we just recovered the hexane because that's where the esters are. Okay? Tapos, ang ginagawa namin, ine-evaporate namin yung solvent so it becomes concentrated and then inject it in GC. So we use an GC FID and GC MS, which you're going to learn later on sa module na ito. Okay? And they said, in every analysis, especially if you're dealing with chromatography, sample preparation really plays a very important role. Sabi nga nila, the strength of your analysis depends on your sample preparation. If your sample preparation is questionable, most likely the results from your analysis, however high-end the instrument that you use is also questionable. So dapat strong link sila kasi kapag weak link yung sample preparation nyo, hindi rin reliable yung results ng analysis nyo. Kahit sabihin yung MS pa yung ginamit na instrument. So question. Kasi yung next dito module, this is just about chromatography already. Okay? So maybe I can discuss to you until the types of the chromatography. And also, I'm trying to look at the recordings that I have doon sa other courses ko dito about instrumental. But the difference is, unlike the Chem 137, Chem 137 is really more in-depth compared doon sa tinuturo kong instrumental, because the instrumental analysis that I teach are for non-science major. I teach it for the clinical laboratory science majors here, CLS. So medyo a little bit mababaw lang yung discussion namin. Wala nga kaming masyadong calculation, mostly on the principle. But when I look at the material here, there are some concepts that overlap. Okay, so I will make that available also to you, because I'm preparing also materials that I have for that in the other college that I'm teaching. Okay? So medyo mababaw yung approach doon, and I try to what we call simplify the discussion that I have there. Kasi hindi mga chemistry majors yung kumukuha nun. So I will just go on until mag-ano tayo sa time. So the history of chromatography started, I think, around 1906, okay, when a Russian scientist by the name of Mikhail Tiswet. Okay, so what Mikhail Tiswet do is he did a crude separation of plant extract, pass it through a column. Okay, so he is an Italian-born Russian botanist who is considered the father of chromatography. Okay, so what he did, he observed the effects of the separation of colored plant pigments into bands using different materials in the column and materials of different particle size. So this is, we could say, a column chromatography. So you have there a tube, you put some solid material there, and you put the plant extract, and he found out that there's some color bands that form. So yun yung principle on the absorption chromatography. Okay, and he presented his result on chromatographic separation in 1903, and he coined the term chromatography, okay, which means color and right. Okay, and this is the inscription that he had in his tomb. Okay, he invented chromatography, separating molecules but uniting people. Okay, so when we're talking about chromatography, this is just a physical method of separation in which the components to be separated are distributed between two phases. So maybe this is not new to you. When you take orgo, you have it, the mobile phase and the stationary phase. So the idea that they have there, the mobile phase will carry whatever components that you have in the sample, and it will pass through the stationary phase where the separation takes place. If you're going to put an analogy of it in nature, so you have there maybe bees and wasps, and then it passed through some flowers. So alin yung magi-stay sa flowers? So usually yung mga bees. So yun yung parang na-retain sila doon, tapos yung wasps, diretso lang yung paglipad niya. So that's where the separation happened in chromatography. So this is the IUPAC definition in 1993. And if you're going to do some classification of chromatography, I think you can separate it into two. The planar chromatography and the column chromatography. The planar chromatography, if you did organic chemistry in person, you experience it. Yun yung tinatawag nating paper chrome, tsaka TLC, the thin layer chromatography. Okay? So planar sila. Now the column chromatography, it passes through like a tube. And you can divide it either gas chrome, supercritical fluid, and liquid chromatography. So we're going to have a module section on liquid chrome, gas chrome, and supercritical fluid chromatography. Now in gas chromatography, you can further divide them into gas solid, gas liquid, and gas bonded phase. Now in liquid chromatography, it can be partition, absorption, ion exchange, size exclusion, and affinity. So yan yung parang magiging basis ng remaining module materials natin dito sa module na to, sa subsection na ito. Okay? And if you're going to look at the major variants of chromatography, you can have a mobile phase that's liquid, okay, gas, or supercritical fluid. And depending on what's the mobile phase, yun yung type ng chromatography natin. So if you have liquid chromatography, your mobile phase are solvents. Okay, so you dissolve your samples in the solvents, and the solvents will be carried out passing through the stationary phase. So ang nagpupush dyan ay yung pressure galing sa mga pump. Now, if you have the gas, okay, so usually the carrier that you have there, the mobile phase that you have there are gases. And then it is carried and it carried the sample and passed through the column, okay, which is your mobile phase. So kapag supercritical fluid naman yung mobile phase mo, gumagamit ka ng supercritical fluid as the carrier. You can use CO2 because you can attain the supercritical condition of CO2 at room temperature, okay? And then in terms of mechanism of retention, it can be adsorption, partition, bonded phase, ion exchange, or exclusion. And then we can also look at the incoming solute profile like zonal, frontal, and linear. We will go over this as we go on each of these chromatography type. And then you can have a column or a planar, like I mentioned to you. It can be a pack or capillary column or a thin layer or paper chromatography. Okay, and then you can have gradient or non-gradient. So when we say gradient, its composition is changing, whether it's in terms of solvent component or solvent composition or temperature program. Now, if it's non-gradient in HPLC, you call it isocratic. So when you say non-gradient, the mobile phase composition is the same, or the temperature program is the same all throughout the analysis. Okay. You can also have a one-dimensional and a two-dimensional chromatography thing. Kung yan ay sa paper chromatography, ang ewan ko yung ginagawa nila. Okay. So, paano mo yung TLC, I think yung paper chrom, so paakyatin mo. Tapos pag umakyat na sila, ibaligtad mo. So, sabi na yan, 2D na yan. Okay. And then in physical scale, it can be multi-dimensional, micropore, standard, or preparative scale. Okay? So meron kasi dito yung parang analytical and meron yung preparative scale. So if you need more sample, you use what we call the preparative scale. If you just want to analyze it, that's what we call the standard or analytical scale. So when we're talking about the mobile phase, that's the one that carries your sample through the stationary bed. So it's a fluid, okay? If it's LC, it's a liquid. If it's gas chrome, it is gas. If it's SFC, it's a supercritical fluid. And usually in GC, the expression that they use is carrier gas, some mobile phase. In elution chromatography, the expression is LUN. Yun yung another term that they use for mobile phase. For the stationary phase, it's just one of the two phases forming a chromatographic system. It can be a solid, a gel, or maniwala kayo hindi, a liquid. Okay? The liquid may also be chemically bonded to the solid. So if it's a liquid, usually it's bonded phase, one that is chemically bonded to the solid or immobilized onto it. So that's an immobilized phase. So another term that they use for this one is either the chromatographic bed or sorbent. Yun yung other terms na ginagamit nila. So ano yung makukuha mong results from this? We call it the chromatogram. So usually in the chromatogram, if it's a GC, LC, SFC, ito yung makikita mo. So ano yung aking mouse. But if it's in terms of TLC, you're going to see some bonds. And you should run a standard beside the bonds. So chromatogram is a graphical or other presentation of detector response, concentration of analyte in the effluent or other quantity used as a measure of effluent concentration versus effluent volume per time. Now in planar chromatography, the chromatogram may refer to the paper or layer with separated zones, like the one that you see below here. Okay, so I think I'll end this thing here. So on Thursday, I may be late because I have an event, and usually if it's a Philippine event, kahit na mag-set tayo ng time, minsan hindi nasusunod, minsan lagi na-late. But I'll try my best to be on time because it's supposed to start at 9 o'clock. But I already have experience before through the webinars that I gave there in the Philippines, that if the event starts at 9, usually it starts around 9:30 or worse, 10 o'clock. So I'm hoping to finish it before 11:30, but I don't know because past experiences tells me that it's always late. But we will continue this one, and I'm going to record some of the other materials that we have here. Tanong? May tanong? May tanong. Wala.
Question, children. Ayan. Wala naman daw question.
So okay lang sa inyo, i-post na namin yung problem set? Submit nyo next meeting before tayo mag-meet.
Bali problem set ito ng module.
Itong module na tinapos natin, ma'am.
3. How did you find module 2? Okay naman?
Hindi pa tapos, hindi ko pa na... kumusta yung last quiz?
Quiz pala, sorry. Quiz ng module 2. Okay naman. Yung may mga control charts. How did you find it?
Nakuha
Madali
ba?
lang, di ba?
Yung iba, ang highest so far na yung parang automated is 27. And I think one of you got 27. The rest got 24, 21. If I'm not mistaken, doon sa accept, reject, withdraw, I think almost all are accept. I think, and one is, I'm not sure if it's with warning or reject. Yung iba hindi ko pa titingnan. So hopefully by the weekend, I can what we call grade them. I'm also having a hell week here during this week.
Saan do makikita yung result sa quiz 1?
Hindi pa pala. Usually dapat after some time it will be posted to you. If ever not, ipopost ko na lang sa inyo sa GC. Because I was hoping that automatically after some time, since I put the settings that you will know the grade after some time. Because may options kasi you will know the grade right away or after some time. So since hindi nyo pa nakikita, I will what we call post that grade. Magagawa na lang ako ng bagong chart doon sa Google Classroom.
Pwede pala yun, Elmer.
Kasi akala ko po...
You can enter the grade sa Google Classroom. Akala ko lang kasi nag-enter doon yung may mga submissions.
Pwede siguro maglagay na lang.
Sige, okay.
Titingnan ko po. Kasi akala ko po, doon sa setup ng Google Forms, since sinet ko after some time, mag-automatic na yung makikita nila yung grade. Kasi yung option
yung
kasi,
scores.
Opo, either makita nila yung scores upon submission or after some times. I don't want it to be leaked doon sa mga nag-submit ng early. Kaya nilagay ko sa settings after some times. Hindi nyo pa nakikita score nyo?
Hindi pa ba?
Hindi nyo sinasabi sa akin?
Hindi pa daw.
Hindi pa po, okay. Sir. Hindi pa po.
Sabihan nyo ako. Akala ko naman nakita nyo. Sorry. Sige, titingnan ko. I will look at it tomorrow. Okay? Tanungin ko si Mark. Kasi akala ko po yung pagdating ng settings na automatic na nila makikita. Okay. Because I'm still even the quill go. Okay? So yung isang nag-email sa akin na nabuksan, I was with Mark and then Mark told me, hala, kailangan na niyang kunin yan. That's why, I'm sorry, I told you, you have to finish it. Because I was with Mark. Because the thing is, meron kasing quota. So ang option doon I have, I think 100 yung quota per month. So, ang option doon is sent sa inyo one time, but that means I'm going to use 42 of the 100 quota. And the other option is send it one by one. So, isa lang yung magagamit doon sa quota. That's why I have to type, I have to email to you the links one by one. Kasi ang ginagamit noon ni Mark, pwede daw i-download yung CSV tapos mail merge. But I think Wilgo got wine of it, kaya hindi sila kumikita kasi lahat yung parang trial lang yung ginagamit. So tinanggal nila yung option na yun. So what I did, every time I emailed the quizzes, I have to email it to 42 of you one by one. Kaya ang ano ko sa inyo, pag hindi pa kayo ready, don't open it. Kasi once nag-open it, kasi sabi nga ni Mark, oh, bakit naman niya in-open? Eh makikita naman na quiz 2 yung ano, yung title nung module na yun. So, kapag lalo na sabi nga, naka-schedule naman na meron kayong quiz, di ba? So sabi ni Mark, hindi, patuloy mo. Kasi kapag hindi na natuloy, eh makikita niyo yung question. That's why I have no option to that student to email me. Sabi ko, you have to answer it since you opened it. I was with Sir Angelia during that time.
Sorry class, ang kaya ko lang checkan yung mata-download ko at mapiprint ko sa hard copy. Pero yung pag sa Google Classroom na automatic, hindi ko talaga alam paano ko gagawin. Paano checkan and hindi, chine-checkan na automatically, di ba?
Yung so, iba po, meron na. Pero yung itong ano isa, kaya nga mangyayari nga ngayon, siguro ang gagawin natin sa quiz, siguro multiple choice na lang, tapos yung problem kung ano yung right answer, and then all the problem solving will be in the problem set. So kaya ang mangyari every meeting, you will have 1 to 2 or 3 problems, lalo na kapag may calculation. And then doon sa quiz, yung parang lahat doon, multiple choice na lang para automatic yung grading.
Pag-check. So sa Google form, yun yung objective. And then yung tapos, sa problem set, yun na lang yung
upload na lang nila. Opo.
Upload na lang.
I'm really sorry that until now, I still don't use my UP account kasi wala pa ho akong UP account.
Grabe. Nasabi na ba yan sa IC? Sino nag-aasikaso?
Di po ba may nangyari kay Ate Mabs? Kaya ayaw ko rin kulitin si Ate Mabs eh. Namatay ata mother niya.
Okay.
Kaya ayaw kong kulitin. Kasi sabi sa akin sa HRDO, yung kaibigan ko, approve na yung appointment mo. Kaso, magtanong ka dun sa IC.
Okay.
Dahil yung nangyari kay Ate Mabs, ayaw kong kulitin.
Okay.
Kaya yung Mirna Merillo, yun yung account na ginagamit ko. So, kasi nagtatawa ko, hi ma'am, sabi doon sa mga email. Ako yun. Nakikigamit ako sa email na yun. I'm hoping that I can get my account and to think this is my second semester teaching in UPLB. Wala pa rin akong account.
Ulitin natin si Ami. Si Ami kasi nasa Analytical Division.
Yeah, baka nga ho alam na ni Ami, baka si Ami nga ho. Kasi yung sinabi nga sa akin ni Rick Rebeccio, yung kaibigan ko doon sa
okay. Oo, si Rick.
Sabi niya, okay na yung paper mo. Kaso doon ka sa IC kasi mamaya malaman nila na binibigay ko sa iyo. Sabihin nila sa akin.
Okay.
Na-approve na nga daw ho. Sabi ko, sige. Nangyari yung kay Ate Ma'am. Sabi ko, ayaw ko muna siyang kambalain.
Okay. I-follow up ko kay Ami.
Opo.
Sabihin ko kasi, iba yung ginagamit mo sa Google Classroom.
Mas maganda nga ata Canvas eh. Wala akong sa Canvas siya kasi sa is. Kaya nga sa pag-submit ng grade, hindi ko alam ano gagawin ko.
Kasi nakagamit ka ng Canvas before.
Hindi naman pero at least similar ata siya sa Blackboard. Kasi ibang-iba tong Google Form sa Blackboard tsaka sa classes na ginagamit ko dito.
Okay.
So question
Okay.
class.
Wala ba? Very clear ba yung mga
At salamat
concepts?
doon sa umattend sa PAASE. Although hindi ko kayo in-invite ata kayo ni Ma'am Gladys. I was just surprised when I saw your name there, but I'm happy you're there. Because we have a big audience. I attended a biology session yesterday. I think mga 30 lang sila. At least yung chemistry, mga 90 plus yung meron.
Okay. So may question si Biel, yung problem set, kailan daw ipopost? So problem set for module 3.
Ngayon.
Sige.
Before I sleep, post ko na sa both section.
Okay. And then, ang June niyan
sa Thursday.
Sa Thursday. Kasi 3 questions lang naman eh.
Oh, 3 calculation question. Yung isa ay medyo challenging, but at least it's about sample prep. It's just based on literature.
Okay.
So, tanong?
And then yung quiz, kailan nyo ipopost? Hindi pa.
Hindi ko pa mag-grade yun kasi hell week ko pa hanggang Wednesday. So mga weekend ko pa maano yun. But I try to post at least the first quiz maybe by tomorrow. I try to see if I can open like a layer there if ever. Kung hindi, i-email ko kayo isa-isa kung i-score nyo.
So ang gagawin ko, i-open ko lang yung Google form and then makikita ko yung scores.
Pero hindi ko po alam kung paano natin i-share yun. Kasi ang kakatakot, pag share natin, makikita nila yung score ng classmate nila.
Isa. Oo nga eh. So siguro, I will try to open the Google form and then record each and then gagawa ako sa Google Classroom ng
kung pwede ngayon parang Google Grade style. Hindi pa rin ako sanay sa Google.
Hindi ako sanay. Bahala na. Continue na lang.
Nasanay lang ako dyan kasi yung anak ko na 5 years old last year, they're using Google Classroom. So doon lang ako naging familiar kasi ako yung nag-ooperate para makapag siya, online class. But not on the teacher side, but as a student side during that time.
Oo. Ang hirap, hindi talaga ako computer savvy. Ma-stress ako pagka tinry ko pang aralin yung mga platform na yan. Gusto ko lang talaga nag-check sa papel. Okay, yeah. So kung wala nang
it's really, kahit nga kami dito in person na, yung iba, they want to submit, online. I told them, no, I want it in paper so I can finish it right away. Because it takes a while kapag nakatingin ka sa computer to the point na nagsuffer na yung site ko.
Oo. Yun ang problem ko eh. Kaya dun sa problem sets nila, nung section ko, pinrint ko yon and then chinek ko. Kaya nare-release ko kagad yung results. Pero pag sa Google form, hindi ako marunong kung paano kukunin ang score nyo.
Because I think yung instrumental class ko, when I grade their lab reports, I think minimum of 2 hours sa computer. Pero kapag yung papel lang, 30 minutes tapos. So kaya,
mahirap eh.
Pasensya na kung medyo mabagal. That's why I think what we do with the quizzes is make it more objective para at least kung tama, mali kayo, may score agad. Mas mahirap yung explanation eh. So maybe ang na lang natin yung mga explanation or especially the problem solving doon sa problem set. Siguro kung meron man sa quiz na short answer lang. Sa tanong?
Wala naman daw. Magkakuha ako ng attendance. Sige nga, open nga your open your camera. Wala ako ng attendance.
Konti lang tayo ngayon
Ilan ang klase mo, Elmer?
17 po.
So 17, ako 24, so dapat 41.
Oh. Wala pa sa 19 lang sila, wala pang kalahati.
Sige, so maybe we have to post the recording.
Mm-hmm. I'm going to
Okay.
send by tomorrow, ipopost ko doon sa Google Classroom.
How about Biel, Benedict, Journey, Joanna, Carl? Wala kayong wala kayong camera?
Mabagal. Yun na nga po kapag nag-aano sila.
Oo nga eh.
Kinakain
Problema
yung
talaga.
ano nila.
Mabagal yung internet. Okay, sige. So ito na lang muna. Let's make the most out of it. Okay. Ay, may issue daw yung kanyang O sige. Ready? Sige, look at the camera. Ready? 1, smile. 1, 2, 3. Okay. Isa pa. Ready? Smile. 1, 2, 3. Okay. Sige. So, lunch na kayo. And thank you very much.